Hey guys, so my optimization problem is going to be on everyone's favorite, the SAT. So recently, my sister approached me about pooling the students that she teaches or tutors the SAT with two of her friends who also tutor the SAT, Sam and Jason. So the main reason they wanted to do this was because right now they all tutor independently of each other, and they have students with very different scores, and it can be really hard to teach someone who is scoring significantly higher than one of your other students. Right? They have different questions, they have different exercises that they need to be doing, and it's very difficult. So their idea was if they pooled all of their students, they could then separate them into 3 classes based on their scores. So here, let's take a general look at our problem, right? So here we have the price that they charge per session, per student. And then here's the amount of students that they think would be interested at that given price. And here we have the number of students that they feel they can effectively teach. So for example, Sam doesn't feel comfortable tutoring more than 5 reading students, 6 writing students, or 7 math students at one time. And then this right here, which is what we're going to be changing in order to optimize our profit, is the actual student distribution, or the number of students in each class. Right, so right now I keep this at 2, but this will obviously change. Yeah, so right here, down here, is our income statement. And like I said earlier, for now we're going to be optimizing profit, preferably with a maximization at first, and then we can play around with that later. And we can see just the general income statement, revenue, expenses, profit, and whatnot. And then the last thing that I want to bring your attention to is over here, my 3 texts. So I could have explained to you the constraints from this solver window right here, but as you can see, it's like really it's just not organized very well, right? So instead, I organize them by the goal that they're actually, which constraint they're actually addressing. And it's just easier because it's color-coded too, so it looks nice. Okay, so, and then lastly, the revenue upper bounds and lower bounds we'll get to later. And yes, so let's begin with our easiest constraints, right? So our 2 easiest constraints are constraint 1 and constraint 2. Constraint 1 just says that you cannot have a negative class size, right? That's pretty obvious. So in order to meet that, you just need one little rule, K8 through M10 must be greater than or equal to 0. Constraint 2 says that the class must be a whole number. That's also pretty obvious. So K8 through M10 must be an integer. Now you also need to make sure that the amount of students in each of the 3, in each subject does not exceed the demand. Right, so here I'm going to compare the sum. So this is the sum of all the reading students and math students and writing students. And I'm going to make sure that that is lower than the demand over here, right? And I'm going to do that with these formulas that I'm going to highlight right there. Cool. And that'll be my 3rd constraint. Constraint 4 is that I do not exceed the individual tutor's comfort class. And let me just put it in apostrophe. Cool. And so basically what that means is that each one of these has a corresponding box in each one of these, right? And I can never have the number in blue exceed the number over here. So if Sam only feels comfortable teaching 5 students in her reading class, then the amount of students that I actually put in her reading class over here should never exceed 5. And so these are just basically saying that each blue one must be less than or equal to its corresponding box over here. Now the hardest constraint was constraint 5, which is that class sizes should be relatively even and tutors should teach approximately the same number of students. Now the problem with that constraint is that Solver doesn't know what relatively means or approximately even, right? Solver is a very binary, always looking for the most efficient. That's what an optimizer does. So for instance, even if Solver has 2 different classes that are equally effective at maximizing profit, it will still put all of the students in one class as long as it doesn't break another constraint. So this was one of the parts that I really struggled with the most, and my solution to it was this revenue upper bounds and lower bounds right here. So basically what I did is I took the revenue per tutor, right? And that was simply the sum product. So 2 times 45 plus 2 times 40 plus 2 times 45, right? And then add them up. And that gives me 260. I then multiplied this number by what I have over here, the range, right? So in this case, it was 260 times 1.1 and then 260 times 0.9. And I did this for all 3 tutors in order to develop the balance. I then told Solver, as you can see over here, that Sam's revenue needed to be within the bounds of Katie's revenue, and that Katie's revenue needed to be within the bounds of Jason's revenue. So what this did is it kind of forced Solver to spread the students instead of just putting them all in Jason's class or all in Sam's class first. Eventually, Sam's revenue would be so much higher than Katie's that it would start to put revenue in Katie's class, and then Katie's revenue would get too high, and it would start putting students in Jason's class. And so we will see how that works in a little while. It's also really important to note that I didn't make Jason's revenue be within Sam's bound. And the reason I didn't do that is because if you do that last one and you make it a full loop, the constraint becomes very, very tight, and you don't get a realistic model. So just the two of them. Sam's revenue must be within Katie's bounds, and Katie's revenue must be within Jason's bounds. Cool. And then, so now that we've gone over our constraints, let's go ahead and run the problem. So all I have to do is click Solver. I'm maximizing my profit down here, which I highlighted in yellow, and I click Solve. And there we have it, right? And you can see, just as I was hoping the constraint 5 would do, it kept the number of total students that each tutor was teaching relatively even. It also kept all of the class sizes, either 5 or 6, right? So it didn't put them all in Sam's or all in Katie's, as it might have done otherwise. Yeah. And so we have a total profit of $1,206.75. So, but that was only, you can't really fully understand that number until you understand the expense side as well. So I basically decided that some of the expenses that they would have, like supplies, would be variable expenses, right? So for the variable expenses, I summed the number of students in each class, and I times it by how much I thought it would cost. So I think each student sitting in the class is going to cost them $2 in supplies. So that came out to $98 per week, right? And for books, I figured even though it wouldn't cost them $2.25 for a book, on average, it would cost them $2.25 for a book. And so I simply summed the number of students in each class and times it by 225. The rooms and advertisements costs I figured were fixed costs, and so I kept them steady. And this eventually led me down to the profit, which is $1,206. But I wanted to make that in more real terms for them, right? So instead what I did is I did the profit per tutor each day. So each time they have one of these Saturday SAT tutoring sessions, each one of them will be taking home $402.25. And so that would give them like a little better of an idea of what they were working for. But then finally I also decided that I was going to see how much they were getting paid per hour. So in order to do that, I took that $402, and I divided it first by 3, 1 for each hour of tutoring, as well as the number of minutes or the number of hours that they were commuting and preparing. As you can see right here, 65 and 60. In order to convert it into hours, I divided both of those numbers by 60. And so any time that they put towards this tutoring endeavor, they're earning on average $79.13. So quite a nice deal. Finally, the one other thing that I really liked about this solver is that if afterwards they decide, you know what, $1,200 is like a little more than we need to have, right? So they can instead begin to play around with the price because the profit is directly linked to the price. They can begin to lower the price and see how much money they would be making if, say, they lowered the price $2 or $3 for each session. And you can see now they make $360 per session and 70 cents. Finally, the last thing that this solver is really useful for is that if you go into the solver and you take out just one of the constraints, right? If you take out just the integer constraint, right? You can now solve for a value of, right? So instead of being like, oh, I absolutely need to have $1,200, I absolutely need to have the maximum profit, you can say, we're really looking to earn about $1,000 total. And solver will solve it for you. Now, the key thing to remember if you do this is that it's not going to give you a necessary integer. So it's rounding. It's telling you about how many students you would need in each class in order to get close to that $1,000 profit goal. Okay, thank you. I hope you enjoyed and learned something.